The lesson in this video covers classifying and angle measures of polygons. A polygon is a closed figure that has all of its sides that are line segments. So in other words, all of the sides are straight edges. There are no curved sides for a polygon. All of the names for polygons are based off of the number of sides they have. All of those names are listed. 3 sides is a triangle, 4 is a quadrilateral, 5 is a pentagon, 6 is a hexagon, 7 is a heptagon, 8 is an octagon, 9 is a nonagon, 10 is a decagon, 12 is a dodecagon. Notice that there's no name for an 11-sided figure, so 11 sides is missing. And then once you get past 12, there's no more specific names. These are called 11, 13, 14, 15 gons. So the number of sides with the word gon afterwards. Also about polygons, that they have the same number of angles as they have sides. So in a pentagon, there are 5 sides and 5 angles. 2 different names for polygons, convex and concave. Concave polygons are ones that have sides that cave in, so they are called concave. Convex polygons are ones that don't have sides that cave in. In the first 2 examples, we're going to first classify whether convex or concave. So these 2 examples, notice the one on the left, the 2 left and right hand sides cave in. That's why it's called concave. The one on the right hand side in number 2, none of the sides cave in. That's why it's called convex. Classifying by the number of sides, number 1 has 1, 2, 3, 4, 5, 6, 7, 8 sides. So this is called an octagon. In the second one, 1, 2, 3, 4, 5 sides. That is called a pentagon. More names for polygons, most of which you actually already know. Equilateral means all equal sides. Equiangular means all equal angles. And regular means both equilateral and equiangular. So things that have all equal sides and angles. So in the bottom 3 examples, we're going to talk about the 3 names we can give these. Number 1, we're going to say convex or concave. This first one is convex. It has 4 sides, so it's a quadrilateral, if I can spell it right. And then the last thing is we're going to decide whether it is regular or not. This has 4 equal sides and 4 equal angles, so it is a regular polygon, a regular quadrilateral. Number 4 is a concave polygon because the top sides cave in. It has 5 sides, so it is called a pentagon. And it has 4 equal sides, but it doesn't have all equal angles. Sorry, it has 5 equal sides, but it doesn't have all equal angles. So it is just called equilateral. It is not called regular. Called equilateral because it has all equal sides. Number 5 is a convex polygon because none of the sides cave in. It has 4 sides, so it is called a quadrilateral. And it has 4 equal sides. Notice that the opposite angles are congruent in this quadrilateral, but they aren't all congruent to each other. So again, this is just called equilateral because all of the sides are the same, not all of the angles. The entire front side of this sheet is all vocabulary. You are going to need to know the vocabulary. So when I say the word decagon, you know that that automatically means 10 sides. On the backhand side, we are going to get into more specific things about polygons. We're going to talk about all of their angles. So we're going to talk about the interior angles, and we're going to also talk about the exterior angles. With the interior angles, there is a nifty little formula that you're going to need to know to figure out what all of the sum of the angles are. So in other words, this isn't going to tell you what each angle is, it's going to tell you what they all are together. So in number 1, if I ask you to find the sum of the angles in a decagon, we're going to use the formula n minus 2 times 180. N is the number of sides. So in a decagon, n would be 10 because there are 10 sides. So 10 minus 2 times 180, and that's going to give us a total of 1440. Now, that doesn't mean that every angle is 1440. It means that if I add all 10 angles together, they would add to 1440. In a 13-gon, 13 sides for a 13-gon, so I'm going to do a similar operation. 13 minus 2 times 180. Doing that process is going to give me a total of 1980. So again, not that each angle is 1,980 degrees, but if I add all 13 angles together, I would get 1,980. For a 17-gon, obviously, my n would be 17 because n stands for the number of sides. So if we do 17 minus 2, we get 15. Multiplied by 180, you get a total sum of 2,700. So n minus 2 times 180 is going to tell you how many or what all of the angles in the polygon add up to. Next three problems are working backwards from that. So I tell you all the angles are 1260. So we're going to work our way backwards. So with our formula, we did two things. We subtracted 2 and multiplied by 180. So for these problems, since we're working backwards, we're going to do the exact opposite of those two things. We're going to divide by 180, and then we're going to add 2 to that total. So if I divide 1260 by 180, we get an answer of 7. Now that 7 is not the number of sides until you add 2 to that total, which means that we're going to have 9 sides. So if I wanted the specific name, because I'm classifying, this would be called a nonagon. The next problem, we're going to do the exact same two steps. First, divide by 180. So if we divide by 180, 2160 divided by 180 gives us 12. Again, we have to add 2 to that to get 14 sides. 14 sides, its specific name is called just a 14-gon. There are no fancy names like pentagon, hexagon, and so on once you get past 12 sides. We're going to skip the third problem and move down. These problems want us to solve for x, so we're going to write an equation for the picture. The first thing I need to do is figure out 1, 2, 3, 4, 5, 6, 7 angles. So what would they all add up to? So we're going to go back to our nifty formula. 7 minus 2 times 180 is going to give me a total of 900. So that means if I add up all 7 of those angles, we're going to get 900 as the total. So we're going to write an equation based off of that. If I add up my x's, I've got 2 with x's, and then I've got 5 with numbers. So if I add the x ones together, we get 3x. If I add all of the number ones together, we get 645. And we just said that they have to all add up to 900. Subtracting. We're going to get 3x equals 255. And then dividing is going to give us an x value of 85. Similar type problem in the next one. We've got 1, 2, 3, 4, 5 angles. So the first thing we do is use our formula to figure out what should all of those add up to. If we do 5 minus 2 times 180, we get 540. So again, we're going to write an equation. We've got in this picture, we've got only one that's, 4 that are labeled with numbers and 1 labeled with a variable. So if I write my equation, x plus 413 should equal 540 degrees. This is a very simple equation to solve because all I have to do is subtract the 413 from both sides, and x comes out 127. So in each of these problems, name of the game, figure out what all the angles should add up to, write an equation, adding all those angles equals the sum, solve for x. The bottom portion of this sheet deals with the exterior angles of a polygon. Now, when we did interior above, you notice there was a formula to figure out what they added to. For exterior angles, there's no formula. It's always 360. So no matter how many side lengths, whether it's a pentagon, a hexagon, a decagon, if you add the exterior angles, the ones on the outside of the triangle, or the outside of the quadrilateral, or the outside of the heptagon, or the outside of the octagon, they're always going to be 360. There's no formula for problems with exterior angles. It's always 360. So if we take that into account, when we write our first equation, we know that the sum is 360. So adding up the x and the two angles, 152 and 137, we know we should get 360. Adding my numbers together, 289. Subtracting 289 from both sides is going to give us an x value of 71. Again, in number 3, we have in this case 1, 2, 3, 4, 5, 6 angles this time, but it doesn't matter. When I add them all up, they're still going to equal 360. So let's take into account we've got two angles that have variables, and we have 1, 2, 3, 4 angles with numbers, and we're just going to add them and give them an equation. So we'll have an equation that says 3x is total plus 252 when I add all of those numbers together, and we should get 360 as our total because they are all exterior angles. Subtracting 252 gives me 108. Dividing by 3 gives me a total of 36 for x. So again, interior angles like above, we have a formula for n minus 2 times 180. The more side lengths and the more angles, the larger the interior sum becomes. The outside, there is no formula because they always add to 360. Always. Doesn't matter how many sides. The last thing we're going to talk about is specific to regular polygons. So if you remember from the front side, regular means all sides the same and all angles the same. So this says find the measures of an interior and an exterior angle. Notice that it doesn't say find the sum of the interiors and exteriors. It says find a single one. So in a hexagon, like the first one, there are 6 sides to that. So let's talk about how we'll figure out an exterior angle. What we do know about an exterior angle is that all of the angles add up to 360, so there's 360 total. Well, if a hexagon has 6 sides, that means it also has 6 exterior angles. So if I know they're all the same, that means I just have to split the 360 6 equal ways. So we do that by division. So that means each exterior angle is going to be 60 degrees. The interior ones are a little harder to figure out. So the first thing we have to figure out is, well, what would all of the interiors sum to? So what would they add up to? That's going to be done by doing our formula, 6 minus 2 times 180. When you do that, you get 720. Now again, that doesn't tell you what each angle is. That tells you what they all add up to be together. So I'm going to do the exact same thing as I did above. I'm going to split that 720 6 equal ways. Splitting that 6 equal ways gives me a single angle of 120 degrees. So here's what you should notice. If you want to do a quick check, look at the two measurements that you got. Think in your head. If you add those together, what do you get? The answer should be 180. That will always happen. If you do a problem like this, the one interior and the one exterior you find will always be 180 when you add them together. Meaning that you can always do a double check on yourself. Did I do this problem correctly? If you did, adding those two answers together will always give you 180 degrees. We're going to do this exact same thing for the next problem, except that we've got 15 sides, which means 15 angles. So exteriors, we know that they add to 360, and we know we're going to split that 15 ways. Doing that gives me one exterior angle of 24 degrees. Interior, the first thing we'd need to figure out is, what do they all add up to? So 15 minus 2 times 180 is going to give me a total of 2340 for all of them together. And again, I want to split that total 15 equal ways, and that means that each one of them will be 156 degrees. So if you want to do a quick check, look at the two answers we just got. If you add those together, you should get 180. So that's a quick check to find out, did I do this problem correctly? When I add my answers together, do I get 180? And in this case, we do. And you can do this process for any number of sides as long as we know that they are regular polygons. That's why we know splitting 6 equal ways or splitting 15 equal ways is what we need to do, because we know all of the angles are the exact same. Make note of any questions you have or any problems that didn't make sense, and you can ask about them next class.